Okay guys, we're going to talk about two more theorems to use to prove that triangles are congruent. Right now, all that I have to prove triangles are congruent is the side angle side theorem, which is one pair of sides, the included pair of angles, and another pair of sides. For instance, if I wanted to show these two triangles are congruent, I could use this angle, one pair of sides, and then a second pair of sides. When I do that, that'll give me side, angle, side, side, angle, side, and the two triangles are congruent to each other. Today we're going to talk about the side, side, side theorem and the hypotenuse leg theorem, okay? So this one is like what it says. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent to each other. That's it. That's all you gotta do. So if I look at this picture here, I've got one pair of sides. Okay, so start to finish, segment AB is congruent to segment DE. That's one pair of sides. Okay. If I use the two slashes, we're also referring to another pair of sides. This means a side starting at C going to B, or B to C, and then side E to F. So that's another pair of sides. That gives me two. So I've got segment CB is congruent to segment EF. And then my last pair of congruent sides right here, they're marked with 3 hash marks. Start to end, start to end. So that's my 3 pair of sides. So I've got side CA, segment CA, segment DF. Okay, 3 pair of sides. 1, 2, 3. That's all I need. That means then that this triangle has to be congruent to this triangle. There's no other way to put those 3 sides together. If they're congruent, then those two triangles have to be congruent to each other. So that means that triangle ABC has to be congruent to A matches up with, notice it's between a 1 hash mark and a 3 hash mark, 1 hash mark, 3 hash mark. These triangles are really flipped over, okay? They reflect on each other. This side goes with this side with this, and then these opposites, okay? So side A matches up with side D. I could put it under. Angle A matches up with angle D. Angle B matches up with E. And then C matches up with F. So it's easy sometimes to write it under, or you could write it to the side. So that gives me my 3 pairs of sides. I know these are congruent because it's told in the picture. It's given in the diagram. I'm going to put given in the picture by the hash marks, right? That's what the hash marks mean. That's true for all 3 of those. That's how we know those. Why do we know the 2 triangles are congruent? By side, side, side theorem. Now, let's go ahead and do one example of that, okay? So we're going to go ahead and write down, just like I did here, except I'm going to do it more with my statements. And then next to it, I'll put the reasons that I am permitted. What justifies, permits me to write that statement. Let's go with 1 hash mark, 1 hash mark. That means side QR must be congruent to side PS. That's what the 1 hash mark means. This is an R. Why do I know that? It's given in the picture. The hash marks, right? The hash marks are telling me those 2 sides are congruent. Now I've got this pair. So from P to Q and from R to S, Does it matter if I go PQ or QP? Nope. Does it matter if I say RS or SR? Nope, it's the same segment. Same thing, it's given in the picture with the hash marks. Now, I've got nothing, no more hash marks and no curves. Okay, there's nothing else directly stated in the picture, but you can see a side that the two triangles share. The shared side is this side right here. That side is shared by both triangles. If I were to split these two triangles and draw them separately, I'd have this one, and know these sides, opposite sides, but then because they share these, that means that length PR would have to be equal to length PR. It's a shared side. So for my third pair of sides, this is a pair of sides, so I have to have the third pair. Even if you didn't know the reason, you could write down side, let me write that again, side PR is congruent to this side or segment PR. Now I'm telling kids, when I say look for a shared side, but that's like what you're looking for. Really the reason two things are equal to each other is by the reflexive property. Think of reflection, right? Reflection, you look in the mirror, see yourself. It's that same idea, except instead of shun, it's the reflexive property. Okay, now I've got enough. I could say the two triangles are congruent to each other, 3 pairs of sides. So that means then, triangle, I'm going to go PRQ. Now I have to match them up. So PRQ matches up with RPS. I think that's the harder part. One way you could think of this, when you look at P here in this triangle, P is between the 2 hash marks and 3 hash marks. So I have to use R because that's between the 2 hash marks and the 3 hash marks. Now, question, can I use angle side, side? To prove triangles are congruent? The answer is no. Okay, the answer is no, because that would be angle, side, side. Look, you got the cuss word, right? You can't write ASS for a reason, but that, oops, you guys, I didn't put side, side, side up here, sorry. Your side, side, side theorem, sorry. And I'm going to show you why in this picture here, okay? Notice if, so it's not the way it is, but if it were, okay, I'm going to highlight on here. I'm going to highlight this side with this side, okay? And the angle where they meet is angle B. They form angle B. This would have to be my included angle. That would give me side, angle, side. Angle B would be my included angle. If I do this side here with this side, they intersect at E. E would be my included angle. So if I wanted to prove these were congruent with 2 sides and an angle, it would have to be side, angle, side, and it would have to be the included angle. This is not what I have given to me. What I have instead is a non-included angle. So that means that this angle up here is not fixed. If you get this, you do. If you don't, don't. It's okay. So I'm going to draw what we have here. We have this side. Okay, we don't say how long this side is. This side A, C, and D, F, we don't know if they're congruent to each other. We know that this angle right here, right, is a fixed angle. Okay, and this side is a fixed side, but this side here, this angle is like a hinge. And this side here is allowed to swing back and forth. So if I were to take that side and swing it, oh, I'm trying to show you something, okay? If I were to take this side here and swing this, okay, it can swing, right? I can, oops, let me move it up. This side here is allowed to swing. It's on a hinge, okay? And I'm saying it's a certain length long. Okay, let's say it's 4 inches long. I could either put the 4 inches here, but then if I swing it, the 4 inches might fit here as well. So if I don't have this fixed, this angle can go here, and I could have this triangle, or I can make this triangle here, okay, where both of these sides are the same length. This is why you cannot do angle side side. So if you understood that, okay. If you don't, it's okay. But what you got to take out of it, you can't write ASS on your paper, so you can't do angle side side. If you're going to use one angle with two sides, it always has to be the included angle. Okay? So let's go down here and talk about right triangles real quick. Right triangles, you're always going to have one right angle. The box is where the right angle is, right? So this is your 90-degree angle. The sides that box points to, okay? The sides that the box points to are always called legs. Isosceles triangles also have legs, okay, right? If you have your base angles, you have your legs on an isosceles triangle and the base. We use that same word leg on your right triangles, but these legs do not necessarily have to be equal to each other. So you remember the box points to the legs. The box sits on the legs. Okay. It is also always pointing to the two sides that are perpendicular to each other. The box points to the two sides perpendicular. I'll write it out. To each other. Okay? Now, the angle opposite the side, not angle, the side opposite this right angle is called the hypotenuse. Okay? So the hypotenuse is always opposite the right angle. Okay? Long word, long side. Okay, you just are going to need to use those words later. So that's why I wrote them. Okay, we're almost there. Yeah. Flip her over. Now, we have another, it's called the hypotenuse leg congruence theorem. So it's another HL. It's another way we could prove triangles congruent. I just told you you cannot use angle side side, angle side side. Okay, if we had to, it would have to be this included angle. That is true, except with right triangles, okay? When you have right triangles, you've used up 90 degrees, this side cannot swing to make two different angles. If it's a right triangle, you can go angle side side, which is called the hypotenuse leg. And I'll show you what we got, okay? Okay. We're going to talk about right triangles. And then I'm going to put the name of this right here. This is a leg. This is the hypotenuse. Because remember the box points to the legs, right? Box points to the legs. And this is a hypotenuse. The third side is called the hypotenuse, longest side, and it's opposite the right angle. Okay. If the leg and hypotenuse of one right triangle.
Pardon the interruption, I have our bus information for this afternoon. Bus 34 is not in service. Students that ride bus 34 home, please remain at the high school, and bus 8 will return at 3:20. Bus 102 is also not in service. Students, please get on bus 58 at dismissal to travel to Critchfield. At Critchfield, please transfer to bus 103. Thank you.
Okay, if a leg and hypotenuse of one right triangle are congruent to a leg and hypotenuse of another right triangle, then the two triangles are congruent to each other. So first thing we have to do, it's like all of them have been 3 pieces of information. Pair of sides, pair of angles, pair of sides, or pair of sides, pair of sides, pair of sides, or you have to show that you have 2 right triangles. You have to show a leg equals a leg, and you have to show a hypotenuse equals hypotenuse. If you can do all of those, then the triangles are congruent. So I'm going to see on this one, triangle ACB is congruent to triangle DFE. You always have to make sure when you write the congruent statement that the corresponding angles and sides line up. A goes with D, C goes with F, B goes with E. Okay, we're going to do one theorem. This one's kind of hard. I'm not going to do the bottom 2. You guys try those, but I'll do this one. This one is hard. So first thing I've got, I want to use a hypotenuse leg. So I know I have to show right triangles. I have to show a pair of legs, and the hypotenuses are congruent to each other. On this one, I am going to talk about triangle JGH. So I'm starting at J, go to G, go to H. So it's this pink triangle. And then we're going to match that pink triangle up with, GJI. So we're going to go G to J to I. So I'm doing the pink one and the yellow one. That is really hard to see, so I'm going to split the 2 triangles up so that it's easier for my eyes to look at. Okay, so I'm going to do this triangle here, which is JGI, and then I'm going to write, all I'm doing is splitting them up. It's the same triangles. Okay, I've got JGH. Okay, so let's just write down what we got. Segment GI and JH are congruent. G to I and J to H. I'm going to put 1 hash mark on each of those, and I'm going to write it here. Segment GI is congruent to segment JH. Why do I know? The given told me. So it's stated in the given. It wasn't even shown in the picture this time. It was just plain old stated. The next one, these 2. Let's mark it as we do it. I'm going to scribble it so that I could see it. From G to H here is perpendicular to G to J. It's perpendicular, so I've got my box right there. Then it says from J to I and G to J, perpendicular. That means perpendicular. So I put this in. They form right angles. So I'm going to write this down here in my given statement. Segment GH, I'm just writing this out exactly how it says, is perpendicular to segment GJ. Now I have segment JI is perpendicular to segment GJ. It's stated in the given. That's why I know it. So that means that these 2 triangles are right triangles. So I'm going to write triangle JIG and triangle, because remember I have to show I have 2 right triangles. So triangle JIG, and then I want to go GHJ, are right triangles. Why? That's a definition of a right triangle. Right triangles have right angles. I could write that. Right triangles have right angles. Now, here's the hard part. All I have is one pair. I've got GI, right? This is my hypotenuse right here. Okay, because these are my legs. Leg, leg, leg. The box always points to the legs. This is my hypotenuse. So all I have right now is one pair of hypotenuse congruent. I know that I have right triangles. So I look at my list. I've got right triangles, I've got hypotenuse, so I got to show a pair of legs are congruent. So I've got to show that two legs are congruent. I think this is kind of hard for a lot of us. This is a shared side. Most of what we've done before, when we shared a side, it looked like that. And this was the side shared. It may have looked like this, where this was the side shared. Okay? This one's harder. I am sharing this side right here. From J to G is right here, right? And it's also right here. That's a shared side. It's in both the yellow triangle and the pink triangle. So side JG is congruent to side JG. Those segments are congruent. Those are my legs. I tell kids to look for a shared side, and that is called the reflexive property. Okay, now I could go ahead and say these triangles are congruent. I've got my pair of hypotenuse. They're both right triangles, and I've got a pair of legs. So triangle JGH is congruent to triangle GJI. And the reason is hypotenuse leg theorem. Okay, that's it. You guys try the rest, see what you got. If you need help, come get it.